Hello, welcome everyone to our ALP Astronomy Expert Speaker Series for 2025. So welcome to the new year as well. I am Dr. Jet Aguilar, and I will be hosting today's webinar. Thank you so much for joining us today, and I am very happy to welcome all our attendees, not only from the Philippines, but also those viewing us from all other parts of the world. I would like to acknowledge also our attendees from the Philippine Astronomical Society, as well as from the Manila Sidewalk Astronomers and the other astronomical groups from the Philippines. Today, we are very fortunate to have with us two prominent figures in astronomy. Mr. Tariq Malik, who is the editor-in-chief of space.com, and Mr. Alan Hale, the co-discoverer of the Great Comet of 1997, Comet Hale-Bopp. Mr. Malik will discuss the rise of giant rockets, Starship, New Glenn, Vulcan, and SLS, and Mr. Alan Hale will talk on the topic on comets and other things. My colleagues from ALP, Mr. Edwin Aguirre and Ms. Imelda Joson, will be introducing our esteemed speakers later. For those who were not able to register, but would still want to watch this webinar, we are currently live streaming on Facebook at the Facebook page of the Astronomical League of the Philippines, where you can view this webinar live. But before we start, kindly allow me to explain some rules for this webinar to help make this an enjoyable learning experience for everyone. Please listen and do your best to give your undivided attention to our speakers. There will be a short question and answer session at the end of the talk of the two speakers. You may type in your questions under the Q&A tab found in your Zoom interface at any point during the presentation. We will do our best to read and answer your questions live after the lectures or via the Q&A tab. However, we would like to remind everyone that the contents presented in this webinar will remain as the individual property of the lecturer and the photographers in the presentation. We will also be distributing certificates of attendance via email to our registered attendees by request. And so please use the name you have written in your registration forms to help us facilitate this process. So let us all enjoy this webinar and have fun learning. Here's the program flow for the webinar. May I now call on Mr. Edwin Aguirre to introduce our first speaker.
Thank you so much, Jet. I appreciate it. Hi, everyone. It is my distinct pleasure to introduce to you our guest speaker, our first guest speaker for tonight, Mr. Tariq Malik, the editor-in-chief of space.com. Imelda and I first met Tariq in July 2011 during the last launch of the Space Shuttle Atlantis, STS-135, at the Kennedy Space Center on Cape Canaveral, Florida. This mission was also the final launch for the U.S. Space Shuttle program. The three of us were covering the mission at the NASA Press Center, along with dozens of other journalists and TV crews from all over the world. After the launch, we wrote an article and we used our photos to illustrate our very first article that appeared in space.com. So that was back in 2011. Now, Tariq joined the New York City-based space.com in 2001, first as an intern and staff writer, and later as editor. He covers human spaceflight, exploration, and space science, as well as skywatching and entertainment. He became space.com's managing editor in 2009 and editor-in-chief in 2019. Before joining the company, Tariq was a staff reporter for the Los Angeles Times, covering education and city beats in La Habra, Fullerton, and Huntington Beach. In 2022, he received the Harry Colcom Award for Excellence in Space Reporting from the National Space Club Florida Committee. He is also an Eagle Scout. Yes, he has the Space Exploration Merit Badge. And he went to Space Camp in Huntsville, Alabama, 4 times as a kid and a 5th time as an adult. Tariq has journalism degrees from the University of Southern California and New York University, and he co-hosts the This Week in Space podcast with space historian Rod Pyle on the TWIT, I think that's the Technology This Week in Technology Network. To see his latest project, you can follow Tariq on his Twitter handle at Tariq J. Malik. Ladies and gentlemen, please welcome Tariq Malik.
Hello, everybody. Well, thank you so much, Edwin and Imelda, for that great introduction, and thank you to the League for having me here. I'm very excited to talk about giant rockets, also what they might bring for the future for astronomy. And I do have a slide deck, a slideshow that we can walk through to kind of give an idea of what's to come. So I'm going to share that right now, and we can get going. So when Imelda and Edwin invited me to come talk about something, I first gravitated towards giant rockets, just because we've got a new slate of huge rockets that could impact astronomy as well as space exploration that are all coming online this year. And so I picked the 4. I'm going to go forward a bit. I picked 4 that are really front and center in mind, and that is going from left to right here. We have SpaceX's Starship rocket, Blue Origin's New Glenn rocket, the United Launch Alliance's Vulcan rocket, which is right there in the middle, and on the far right is NASA's Space Launch System, which successfully flew to the moon a couple of years ago. And I'm really excited because just a little bit about me, and I know that Edwin talked about it a bit. I'm a big rocket fan. As Edwin mentioned, I joined space.com back in 2001, and it's hard to believe, Edwin and Imelda, that it's been over 12 years since we first met and at the STS-135 mission itself. But there at the top on this, you can see me with one of the space shuttles. I think this was Discovery for one of my earlier missions because I look much younger in that image. And just because to illustrate that it's been a lifelong passion of mine down there on the lower left. It's a photo when I think I was about 15 years old, and my mother, who's there on the far right, took me, my sister, and my cousin to the Kennedy Space Center, which is where I'm at in that top picture too. And we saw the Saturn V rocket that was there. So it's something that bit me as a space bug when I was very young, and I'm very fortunate and appreciative that I'm able to proceed in it today. And so as I mentioned, the two of the rockets that we see here on the left, the SpaceX's Starship and New Glenn, are in the news recently, and we're going to touch on that because they both launched in the last 2 days, actually on the same day of this week as we're recording it. But we're going to actually start with, I believe, SpaceX's Starship, largely because this is the world's largest rocket. So if you haven't heard of Starship, it's probably one of the most attractive news bites in terms of spaceflight right now. But this is a SpaceX rocket announced by Elon Musk back in 2016, and it first launched in April of 2023, so not too long ago. And then on January 16th, that's this week, it launched on its 7th flight. It's designed to be fully reusable, which is very novel in the rockets that we're talking about today, because it is supposed to be a fully recyclable spacecraft, one that can launch over and over and over again, take astronauts into space, take satellites into space, and take the future giant space telescopes of tomorrow into space as well. But it is like a monster of a vehicle. It is 400 feet tall. That means it's the size of a 40-story building, about 120 meters for folks on the metric system, and it has a 9-meter wide fairing. That's bigger than anything that is in use today. So about 30 feet, and that it's one of those types of sizes that it could use the big, like it could even fly like the biggest space telescopes that scientists are dreaming up right now. It uses a very interesting fuel. It uses liquid oxygen and liquid methane to get its higher performance, and it can carry up to 150 metric tons into space in its fully reusable mode, and 250 metric tons when it's expendable. And this is just a size comparison to try to help everyone picture how large this rocket actually is. That's actually it's the background of our talk here. You can see it right over this shoulder, right there. But all the way on the far left at 2 meters is like your average person, and you can see how tiny and minuscule we are compared on the far right to this giant rocket overall. Those two vehicles in the middle are the Millennium Falcon from Star Wars, which is what Elon Musk named their Falcon rockets after because he really likes Star Wars. And in the middle there is the Falcon 9 rocket, which is the rocket that SpaceX launches the most. They launch them multiple times a week. In fact, I believe last year they launched over 100 of them. What they are hoping is that this new rocket that you see here on the far right will replace their Falcon 9 as a workhorse rocket, that it can carry so much more in terms of satellites and space telescopes and exploratory vehicles into space in the future. And then right here is just a look at the two different parts, because I mentioned that it was reusable, and it is a massive spacecraft. So this is the actual Starship version. If you look at the picture behind us, this is the part that's on top. It's about 52 meters tall, 171 feet, and it uses fins and flaps to launch itself into space and come back to Earth. This is the upper stage of a 2-stage launch system, and they call it Starship. They also call it Ship as well, and it's made completely out of stainless steel, which was a decision that SpaceX's Elon Musk made at the time because they wanted to be able to make a very robust and hardy spacecraft so that's not too fragile, but they also wanted to make it very quickly and at scale, kind of like in a factory. And so they hired a lot of welders, got them all experienced in how to build spaceships, and now they have this vehicle itself. As I mentioned, you can see over here that it's 52 meters, it's 9 meters wide, and it has a very high payload capacity of up to 150 tons. The super heavy right here is the booster part of it. So this is the part that SpaceX will use at the beginning to launch into space, and it's much larger, nearly twice the size at 71 meters tall, and again it has just a massive amount of thrust. This rocket in particular uses 33 separate engines. I've got another slide about that in a bit, but it is the most number of engines ever that fire together in use today. And when you connect both of these, and here's a look at those engines in action right there. That was our opening slide as well. So this was a big record-setting thing. In fact, a lot of people didn't think it could be done, that you could manage that many numbers of rockets there, and of engines at the same time. But SpaceX was able to do it because they've been gradually scaling up their rockets over time to enhance the performance of their vehicles. Their first rocket had just one Falcon engine, their Falcon 1 rocket. Their Falcon 9 has 9 engines, and now this one has 33 on the first stage. Coming up next is a quick video, which might have an ad, so I apologize if that's the case. Let's see. Here we go. And this is just a quick look. Yep, this will have a video. We'll mute that for a minute while we get through it. But what I'm going to show you right now is SpaceX's Flight 5, their 5th space flight of the Starship system. SpaceX has launched 7 of these flights so far, most recently on January 16th, and that one was a little bit special because they lost that upper stage. This was almost a fully successful flight. They launch out of South Texas. Here we are lifting off right now. Massive getting off the ground. You'll see in a minute it's going to shake their mission control right there. Those cameras were being shaken by the force of the rocket. And it moves very slowly getting up because it's such a huge vehicle. Now this is a slow motion version, but when I watched it back in 2023, the first launch, it was very noticeable how slow it actually moves off the ground. The fact that they've been able to get these off the ground, they've been very, very excited about it. I just want to get a little bit more right here. This is an amazing view where you see the separation of the rocket as the
stage separation. Booster.
So that alone is really amazing. And then all of these views that we're seeing are coming courtesy of SpaceX's Starship rocket. But I do want to see one thing right here. This is the part that really sets SpaceX apart. They brought the rocket back as they do with their Falcon 9 rockets, and they're able to steer it all the way back. And we've seen this before with SpaceX's technology, with the way that they have their landing rockets and they return them to land offshore. This is something that SpaceX has never done before, that no one has ever done before. They brought it back to the launch pad, and this is part of their big plan to be able to launch these over and over again. And you can see this, it just approaches the pad. They call it Mechazilla, like Godzilla. And it has these two big arms that they call chopsticks. And I'm just going to be quiet right here so you can see what happens next.
We can see those chopsticks now. This is absolutely insane.
So they're able to catch the rocket after they launched it at the same place that they launched it from. And this is something that SpaceX hopes is going to be revolutionary in, let's see how I can get back to it. There's this, pardon me.
Attention all flight members, this is the final go-no-go poll for operations.
There you go. I got a lot of these windows that opened on accident. So there we go. Wonderful. We'll go one more. And we already showed the landing. This is something that SpaceX hopes will really help them launch many payloads into space, private vehicles, private missions to into Earth orbit. They want to use this vehicle to go on missions to the moon in a bit, which we'll talk about. But they right now they are launching out of Boca Chica, Texas. This is if you've ever seen a map of Texas in the United States, it's a very huge state, but at the very southern tip is like a little point. That's where SpaceX is launching these rockets from. They call it Starbase, and this image here shows that launch pad that we just saw the rocket land at, and behind it you can see big towers and whatnot. Over here, those are the high bays where they've been building these rockets, and SpaceX hopes that by pioneering this type of giant rocket, they can launch future space stations, future space telescopes, and habitats and astronauts to the moon. Eventually, they will shift to the Kennedy Space Center. They are building a version of this structure there. And in fact, they're building a second version of this structure at this South Texas site as well to fly more missions more often. So that's a real quick snapshot look at Starship. Starship is actually one of two vehicles that we're talking about in this talk that NASA is looking at to launch a telescope that they hope will find life on other planets called the Habitable Worlds Observatory. And so this is one vehicle that could carry that space telescope, because it's much larger than even the James Webb Space Telescope, which currently is the largest space telescope we've ever sent into space. The first launch, as I mentioned, was back in 2023. I got to see that one launch, but it did fail. It exploded short before it could even reach space. They reached space for the first time with this rocket in the summer of 2024, and then in October of 2024 was the launch that I just showed you, which was where they managed to catch the booster, and then they also landed the ship in the Indian Ocean. Now, Flight 7, which is the most recent one, was on Thursday of January 16th. That's this past week here in the U.S. They managed to catch the booster again, which was great, but the spaceship failed on the way up, and it actually exploded. So if you've seen reports about debris raining down over Turks and Caicos, that's what that was. In fact, I just saw a video of it before we were coming on, of what that looked like from an airplane. It's a pretty big setback for SpaceX. So there is an FAA investigation going into that. So currently, SpaceX has already sold passenger flights both to the moon as well as into orbit with this vehicle right here. However, they're a bit delayed in what they need to get it to go forward, because in order to build private space stations or to get astronauts to the moon. NASA wants to use this rocket to get them to the moon, to get the Artemis 3 astronauts to the moon. SpaceX has to launch a lot of these. They hope to launch maybe 25 of these this year in 2025 alone. But in order to get to the moon, they have to launch something like 15 or 24 of them all at one go, and to do fueling like you see this in space, in order to get astronauts to the moon. Like this. This is their big plan for the moon mission. So they do have a long way to go in order to fulfill the promise of this vehicle, but it is one of the few that are already flying that we're going to talk about. Up next is Blue Origin's New Glenn rocket, which by a sheer coincidence launched its first flight on the same day as SpaceX's Flight 7. And New Glenn is Blue Origin's, and I might say SpaceX a lot because I'm used to talking about SpaceX, but New Glenn is Blue Origin's big entry into the heavy lift market to be their competitor with SpaceX's both Falcon rockets as well as the Starship. You can see that it's the versions of New Glenn are these three rockets over here, and just like SpaceX's Starship, it was also announced by Jeff Bezos, the owner of Blue Origin, in 2016. It's named after Mercury 7 astronaut John Glenn, and it's almost as tall as the Starship at 320 feet or 98 meters. What is interesting is it's also quite large in terms of its width. It's 7 meters. Remember, Starship was 9 meters. So this is still quite large compared to the rockets that are flying today, which are about 5.5 meters wide. That's what most satellites and payloads and spacecraft are built to accommodate. They use a different fuel for it. They use liquefied natural gas for their first stage, and then a more traditional liquid hydrogen. And they can launch up to 45 metric tons into orbit. And it is also designed to be reusable. You can see on the left over here, this two-stage version is the primary one. They hope to build a three-stage version that's more capable. And then this whole part right here in the middle is the first stage that is supposed to come back and land much like SpaceX's rocket. The Saturn V there is for scale. And hopefully, I mean, at the time they were hoping it was going to be the biggest rocket, but it actually ended up not being the case because Starship is quite larger. In order to build this rocket, New Blue Origin built a smaller rocket, which you can see up here in the nose cone. It's called New Shepard, named after Alan Shepard. I know there's a lot of text on this, but their first rocket, Alan Shepard here, was a suborbital rocket that they use now to fly tourists into space, and they could fit an entire one of those in the nose cone of this rocket itself. The first stage, which is down here, uses 7 engines that Blue Origin calls BE4 engines that use that liquefied natural gas, and the upper stage uses 2 of a smaller engine that they've developed. So they've managed to evolve their suborbital business into this orbital class rocket, and then reach orbit on the first try, which was pretty exciting. And this is just a close-up look of those engines, just to show how large they actually are. This is your average female adult, and then the engines are right here. This one on the left is the first stage engine, and the ones on the right are the larger vacuum engines for space. Now, the New Glenn rocket functions a lot like a SpaceX rocket, in which the rockets will lift off the ground, fly on a regular ascent profile, and then the first stage separates and then comes back and lands on a platform at sea. This particular graphic was their actual test flight that Blue Origin flew on January 16th. It was about a 6-hour flight. They didn't fly a payload or anything, but they did test the payload nose cone jettison and those types of things, and then they burned everything up in the ocean. They're very excited that this whole thing went according to plan in terms of reaching orbit. However, they did want to try to land the rocket booster on the first stage. This is an illustration of what that would look like. They named their barge for landing Jacqueline, which is Jeff Bezos' mother's name, but they were not able to actually land the rocket at sea on this try. So they're going to hopefully try in the future. They're not sure like what happened, and we're still waiting for details about it. But I do feel that it's interesting to note around the bottom here, you can see these little spidery legs that are sticking out from the bottom of the booster. Unlike SpaceX's rockets, which have their legs that fold down almost like a like a book opening. Blue Origin has built their legs into the body of the spacecraft, and they kind of pop out and extend. It's a very sci-fi looking thing to see. But hopefully they'll be able to fix out whatever bugs they had on this last flight, and they'll be able to land on the next one. And right here, I believe I have a video. Yes. This is just a very quick one, and I apologize, it's not at the right spot, but we're going to get there right about now. This is a look at what happened. They launched their first mission at 1 a.m. in the morning from Cape Canaveral Launch Complex 36 in Florida. And you can notice this also looks like it's moving quite slowly, and that's just because it's such a large rocket that it takes a while for it to really get moving. And you know, the fact that this got off without a hitch on the first try, I think was really amazing to see. Almost every launch vehicle that I've seen go on a test flight has failed somehow on the first flight, mostly the SpaceX rockets. But Blue Origin managed to reach orbit for the first time. That's those 7 BE-4 engines. It has a weird blue flame because it uses that methane gas, or that liquefied natural gas that we were talking about earlier. Blue Origin was able to do it on the first try, and that's critical for them because they needed 2 orbital missions in order to qualify for other national security and other national missions, like for NASA, for the military, and for their customers as well. So currently, we've got this one launch that just happened. They reached orbit for the first time, but their first landing was not successful. That doesn't mean, though, that it was a failure for Blue Origin and for New Glenn. They're already on contract to launch NASA's twin Mars mission, Escapade, which we expect will happen sometime fairly soon. And then they've also got plans to launch a whole satellite of or a whole constellation of Kuiper internet satellites for Amazon. That's their answer to SpaceX's Starlink spacecraft and satellite constellation. Meanwhile, they're going to be launching a number of other national security payloads in the future. So they've got a lot of contracts lined up, and they're on a really good pace for this. And eventually, when they're able to start recovering the first stages and reflying them, they'll be able to lower their cost. And then you can see on the last one, they are aiming to go to the moon. Blue Origin is developing their own moon lander that they call Blue Moon, and they do want to carry astronauts to the moon for NASA on a future Artemis mission. So that is part of why they're building such a large vehicle with such a large width, so they can do that. And they also want to build a private space station called Orbital Reef. And to do that, they need to be able to have a heavy lift vehicle. So they've got big plans for this rocket, and it could benefit not just the astronomical science by being able to lift a large payload like that Habitable Worlds Observatory that I mentioned, but also carry future passengers to the moon, future space stations, and whatnot. And then coming up is the United Launch Alliance's Vulcan rocket. This is the first of the more conventional rockets that we're going to be talking about. SLS is the other one. And you can see here that it already starts to look a little bit more familiar with what we've seen before. But the United Launch Alliance has developed this new rocket to be their new workhorse vehicle. The United Launch Alliance is a partnership of Lockheed Martin and Boeing. They've been working together for at least a couple of decades now to serve national interests for launch. So they've launched Mars rovers, they've launched spy satellites, they've launched communication satellites, as well as missions to the outer planets themselves to explore our solar system. But their system was fairly old, and they wanted to build a new rocket, Vulcan, that uses a lot of U.S. parts instead of relying on Russia for engines and whatnot. Like the other 2 rockets we talked about, this one was also announced in 2016. It does seem like that was a big year for these new rockets to be announced, and it first launched in January of 2024. So it's their 1 year anniversary this month. It's still a very big rocket. It's about 202 feet tall, 62 meters, but its width is a bit more traditional at the 5.5 meter diameter. That's very traditional for most rockets, and that was just something that they made as a business decision. It also uses liquid oxygen and that liquid natural gas as a propellant for its first stage, because it uses the same engines that Blue Origin uses on their New Glenn rocket. They've actually bought the engines from them for this vehicle, which is very interesting to do. And it comes in a variety of flavors. It comes in a 2 booster form all the way up to a 6 booster form, like with strap-on boosters all around it, and that will allow it to have a very flexible flight profile, so it can launch regular satellites, it can launch space telescopes, and it can launch larger, heavier payloads to the moon, perhaps, or beyond. They hope that it will be able to launch up to 30 tons of payload to the low Earth orbit with the 6-booster setup, or 12 tons of stuff to the moon, which is pretty big. In fact, even without the 6 boosters, it can launch to the moon anyway. That first flight that I mentioned went to the moon with a small probe, and we're going to talk about that in a little bit. This is just a look at what the vehicle looks like itself. You can see on the left, these are the Blue Origin engines that they're using right now on the rocket, and these are their optional positions for their solid rocket boosters here around the first stage. The United Launch Alliance has their own homegrown upper stage called the Centaur, which they are developing an enhanced version of that will improve the capability of this rocket, so it can launch bigger space telescopes, bigger observatories in the future. And then at the top is this 5.5-meter payload fairing that, while it's the same kind of traditional width, United Launch Alliance has built it in a way that they can actually extend it, make it longer to include not just one satellite, maybe 2 spacecraft, in a big collection of CubeSats, to give it even more flexibility over time. And this chart here, just the red here, shows you the mass of what Vulcan Centaur rockets can take. The blue is the Atlas V, and you can see that the stark difference. The Vulcan Centaur rocket can just carry much more in their high end, and that's a big attractive selling point for this rocket for future space missions. And I think there was a video here. Yes.
Horizon is
And I apologize again, we have an ad here for this one here. But the interesting thing about this rocket is that they've not just flown once like New Glenn, but they actually have launched several times. And I'm gonna get to that launch really quickly, because something very interesting happened on this one. And we're gonna look at it right. Yeah, here we go. So here it is lifting off.
Of the United Launch Alliance Vulcan rocket.
This was actually in October of 2024, and they used the 2-booster variant. And a very interesting thing happened on this flight that they're studying, because it was something that they didn't expect, but it was also something that was an interesting capability of the spacecraft. Very shortly, you're going to see in the booster that we're watching like what looked like a pop or an explosion that came off, and that was a nozzle failure or a nozzle anomaly on this rocket itself. And the first flight back in January, there it goes. You just saw that big flash there. The rocket, something happened to its nozzle, and it started to flare out. And you can see the rocket is tilting over to the right. Now it has straightened itself back up again. And the reason I bring this up is because that is the kind of failure that could have doomed any other rocket in the past. But this rocket had some upgrades to its avionics that allowed it to correct itself. It noticed that there was a problem in its trajectory, and it was able to fix it so that it could get itself back on track. Now it did not fly all the way to its proper altitude on the stage separation, but it was able to recover that with the upper stage, and so it made it to orbit just fine. And then right here is there's the moon mission that they launched in January of 24. This was an astrobotic lander. I include this here just to show that these aren't just for satellites. They're actually doing interplanetary and solar system flights. These missions are. This was a NASA commercial mission that they had put a bunch of experiments on an astrobotic peregrine lander. And unfortunately, this lander itself was not able to land on the moon. It developed a leak on the way out there, and when it came back, it had to re-enter Earth's atmosphere. It ran out of fuel to land on the moon. So then finally, just for this mission, we talked about reusability for both SpaceX's Starship as well as the New Glenn rocket. Initially, ULA did say they wanted to reuse the engine component here of the ULA rocket. What they would do is they would launch into space, the engines would pop off in a little module, deploy a heat shield over here, and then use a parafoil to parachute down, and they would catch it in midair and be able to track it that way. They haven't talked about that very much recently, and it sounds like it's something that would be incorporated much later down the flight. But as we mentioned, the current status, they're gearing up for their third flight later this spring, in which they're going to launch their first national security flight. So they seem to be on a very good clip for this one, and it will soon be their primary rocket for launches, replacing the Atlas V overall. So, and of course, that question mark about reusable first stages. And then the last rocket we're going to talk about in detail is NASA's Space Launch System. This will be a fairly quickly because it is a bit old now, but I include it here because it is a rocket we expected to launch this year. And this is NASA's big mega rocket to go to the moon. This was actually one of the oldest designs of rockets. It was first envisioned as part of NASA's Constellation program as the Ares 5 back in 2004, and they used that design to evolve it into this space launch system that was announced much later during the Obama administration when they were recycling that program. Its first flight occurred on November 16th of 2022. That was the NASA Artemis 1 mission that went to the moon. And like SpaceX and New Glenn, it's a very big rocket, 322 feet, 98 meters. It has that more traditional 5.5 meter diameter, and it also has a more traditional propellant, liquid oxygen, and liquid hydrogen. Now, this all is very familiar because it uses a lot of the same stuff that NASA used for the space shuttles. In fact, it uses a version of the NASA space shuttle rocket boosters that you see here. They're just a bit longer. Instead of being 4 segments, they have 5 segments overall. And these engines here, if they look familiar, it uses 4 RS-25 engines. Those are the same space shuttle engines that they used during the space shuttle program. In fact, they're the same engines. NASA is actually flying their space shuttle engines that are left over from the shuttle program on this rocket, and then when they run out, they're going to be building more. And then, as you can see over here, it's designed to launch the Orion spacecraft to the moon, and this is their crewed version of it to carry astronauts. Eventually, they want to have more, and we're going to talk a little bit briefly about that. This is just a quick look at how that Artemis 1 mission did go. It was about a 40-day mission from Earth to the moon and back, where they launched the Artemis spacecraft on the SLS rocket. It went up to the moon, looped around the moon in a very long orbit, and then came back to Earth. And a very successful flight overall, but there were some delays. There were some glitches that have caused a longer delay. But it did actually, this is, I think, a video. Is that right? This is just a quick video
Our return to the moon will
of the mission itself.
of the lunar surface
The
and learn
space
how
launch
to
system
live.
I
is
think
now
we start
counting
right
down to
about
liftoff of
here.
a 4-stage engine start. 3.
Now, at the time, this was the biggest rocket to fly, and it held that record for about 6 months before SpaceX launched their Starship rocket, which then took that title. But this was NASA's big investment. This is what they want to be their primary rocket to get astronauts into space, to the moon, and hopefully beyond if they're able to get through. That's the escape tower. Here's a view inside the Orion spacecraft, and coming up, I think, is like the really selling point of this rocket. It uses these solar arrays on a European-built upper stage or service module on the Orion spacecraft that can take pictures of just the spacecraft all the way out to the moon and back. The images from this mission were spectacular, and this was the first time we've gone to the moon with a crew-rated vehicle in the 21st century. You know, not since Apollo has NASA done this, and it was actually very spectacular to see. Sadly, I was actually there for the first 2 attempts to launch that rocket, and they scrubbed them both times. But this is my favorite part that came from that mission. This is a selfie that the Orion spacecraft took beyond the moon. You can see the moon out here and the Earth in the background. It was a record-setting mission. They broke a record for the farthest crewed capable vehicle from the Earth. And eventually NASA had hoped to make them a lot larger. There's a cargo version of that SLS rocket that we just saw here. They would want to add bigger exploration stages to launch more, because this was supposed to be their primary rocket to get to the moon, to launch space station components and other types of vehicles overall. In fact, the Europa Clipper mission, which just launched to Jupiter, was supposed to launch on this rocket, and then they shifted it to a Falcon Heavy because they were going to miss that window. So there were delays developing the rocket that have really impeded its performance. However, right now they are training a crew to fly on the next one, the Artemis 2 mission. And that is that these astronauts right here. In the center is Commander Reed Wiseman. Up top is their pilot Victor Glover. Christina Cook is the mission specialist, and representing actually Canada is Jeremy Hansen there. Now they're waiting for their flight. But that Artemis 2 mission has been delayed until September 2026 because of issues not just that came up during the reentry of the Orion spacecraft. There were cracks in the heat shield that they didn't expect. They're trying to figure out how to prevent that, if it's really safe for the astronauts to fly. But you can see here that the core stage of the new rocket, the Artemis 2 rocket, is being assembled right now at NASA's Kennedy Space Center. So they are preparing that vehicle. It's targeted to launch in 2026, but that delay of over a year and a half has really pushed back the plan to have land astronauts on the moon. That's not going to happen until 2027 or beyond at this point. And as I mentioned here, those astronauts are preparing for flight, but there is a new administration taking charge in the U.S. President Donald Trump will be inaugurated on Monday, and that administration change always comes with changes in the priorities of the national space program. So whether or not this rocket survives the next administration, or if they cancel it for something else, we're still waiting to see, because it could very easily be canceled because it's so expensive and so over budget. And then finally, there's just a slide is China's Long March 10 rocket. I included here because China and Europe, they have their own heavy lift vehicles. Europe has the Ariane 6 that they've got flying. It can't carry as much as the other rockets we talked about, but China is also developing the Long March 10, which we thought was going to fly this month or this year, but it's looking like it's mostly going to be next year. And this is another huge rocket that they're hoping to launch to the moon, to launch space station components for the future. So it's not just a U.S. Project. These giant rockets, they are taking shape around the world. In fact, China has plans to build a version of Starship themselves too, after seeing the success of what SpaceX has done. So it's very exciting because all of these rockets that we're talking about can be capable of launching not just astronauts or space stations, but space telescopes that are going to peer deeper and farther into the cosmos, and much larger ones that can go even deeper into those secrets for the universe. So I'm very excited to see that. And that's my presentation. Thank you very much. So this is a picture of me with the very first Starship 1, which sadly was the one that blew up on that first flight back in 2023. So, and I think I have to stop sharing, right?
Yep. Thank you, Tariq.
There we go. Thank you.
Okay, we're good. So thank you so much. Wow, that was a very comprehensive review of the current status of our giant rockets. And we got everything that we ever wanted to know about these rockets. So thank you so much for sharing that, Tariq. Now we will proceed to our Q&A section. I believe we have some questions here. I have to access it. There was one question here from the amateurs. Of course, we will go into the details first about your talk with the other questions, but this is more of a general question and concern from amateur astronomers who do a lot of astro imaging. So amateurs are still concerned about the impact of Starlink and similar satellite constellations affecting the night sky, and how successful are the attempts to mitigate satellite reflectivity by SpaceX?
You know, I was just at the American Astronomical Society meeting earlier this past week, and that's a question that is still being discussed right now. You know, SpaceX actually seems to have they've developed the coatings to make their satellites darker, but they're not the only people that are launching mega constellations into space. And so it is an ongoing concern, and I think it's one that we don't have an answer to just yet. There are several other companies. We mentioned Amazon's Kuiper satellites. There's another one called Space Mobile that has satellites the size of tennis courts that are very, very bright. And I believe that this kind of this kind of interference is one that's going to be going on over time. SpaceX wants to launch up to 32, or if not more, 1,000 satellites into orbit, and they say that they're mitigating it, but a lot of astronomers are just having a really hard time getting clear skies for that. So I would say that it's still a work in progress to try to find that middle ground.
Thank you. So here's another question. What are your sources saying about the possible cause of the explosion of Starship shortly after launch?
Yeah, so far, what we're hearing, at least from SpaceX and from Elon Musk, is that there was a leak, a fuel leak in the upper stage, that ship vehicle on ascent. So while it was doing its final burn to get into space, and because it had that leak, it started a fire, and then that fire led to an explosion that destroyed the vehicle. Now, SpaceX has a lot of cameras inside and around the vehicle, so they should have been receiving telemetry all the way through there. But right now, that's kind of their best guess, is that they developed that fire. Now, they do have to figure that out. This is a vehicle that's eventually supposed to carry astronauts, so having these types of leaks that can destroy your spacecraft is not optimal. But at least they seem to know where in the fuel compartments it developed, so that they can look at that for the next vehicle itself.
Yeah, thank you. So were there any reports of damage or injury from falling debris from the Starship?
I haven't heard any reports of damage or injury yet, but I've seen just a number of very clear witnesses seeing the fireballs and the debris re-entering the Earth's atmosphere. We were talking about satellite disruption to astronomical observations earlier, and debris burning up and re-entry debris is another concern for astronomers as well as for scientists on Earth, because it just causes additional pollution and disruption in the atmosphere. I did hear that they did have to reschedule a lot of flights, basically divert a lot of flights around the reentry profile because of that falling and surprise debris. And that's going to be a big question that comes up in the FAA conversation as well.
Thank you. Here's a question from one of our attendants, Dante De Jesus. Does SpaceX build their own rocket engines?
Yeah, SpaceX uses a ground version called Raptor. Raptor 2, I think, is what they're on now for the Starship vehicles. And then they have a vacuum version for the upper stage, which uses 6 engines. I didn't talk too much about that. But so each of those they build in-house. And in fact, they're churning out something like an engine or 2 a day. It's a massive amount. Now, we were talking about how this is the 7th flight of Starship. Imagine that's 39 engines on every rocket. And they've launched 7 of them, and they've lost almost all of them, and so they're losing those engines over time. So they have to be able to build them up very quickly. So they think that they can launch, I think, or develop an engine a day or faster than that eventually with what they're scaling up. But they build everything in house so they can control everything.
Thank you. This question from Patrick Stonehouse. From your point of view, which country will land humans on the moon next?
I think that's a really good question. The United States really wants to land astronauts on the moon by 2027. However, because they're using Starship, which does seem like it has a lot more tests to go through, it seems like that's a very ambitious schedule. Meanwhile, China says that they're trying to get an astronaut on the moon by 2030. They seem to be making progress on that, and that's a very realistic goal for them. India says that they would like to are aiming to build a space station around the moon by 2040, and then follow that up with a crew landing. So right now, it does really seem to be a bit of a race between the United States and NASA and NASA's international partners, because they are teaming up with Canada, Europe, and Japan, and perhaps Russia as part of that. It's unclear, and then China right now at that point in time. So I think we have to see how the technology develops.
Is there? I've heard that India is also.
Yeah,
Yeah.
India is looking at more in the 2040 timeframe right now, because they would like to launch their first astronauts by the end of this decade, and perhaps in the next like 3 or 4 years. But that's just to low Earth orbit. They haven't built the rockets yet to reach the moon, but that is a goal for them. So they want to build a space station around the moon by 2040, and hopefully have a landing sometime after that.
Okay, thank you. And from one of our panelists, June Lau, the question is, with the increased number of space launches across different countries, is there a regulatory agency, maybe an international regulatory agency that now manages all of these launches?
Well, right now, the Federal Aviation Administration has been tracking a lot of these launches, and the bulk of these have been coming from SpaceX, and therefore FAA is kind of overseeing that for SpaceX. But in terms of like a wider agency tracking all launches around the world, there isn't one that encompasses all of them, and it's why we see a lot of separation between how debris, for example, is treated in the United States or with U.S. launches versus some that are from China, where like the debris can fall on nearby populated areas. That's a big risk that SpaceX is supposed to avoid with the FAA. So.
Okay, thank you. So from another question here regarding NASA's Artemis program. NASA's Artemis program has been plagued by delays, cost overruns, and technical challenges with its critical components, including the Orion spacecraft and the SLS booster. How will these issues impact America's planned return to the moon this decade?
Well, the delays are very frustrating for sure. You know, when the original Constellation program that inspired the SLS rocket was in place, they were supposed to land in 2020. That was 5 years ago, and they were supposed to land in 2024 with Artemis 3. That was last year, and clearly they haven't met any of that. So there have been a number of substantial cost overruns, as well as the schedule impact delays that are really pushing the schedule back. Plus, NASA is dependent on SpaceX to build this lander, which will need 15 to 24 Starship launches just to fuel the rocket and to get it to the moon. That's a lot of flights. Plus, they haven't tested their fueling technology, their spacesuits, and all of that. So there's a lot of open questions about it that have really added to delays. And because I mentioned we've got this new administration coming in, all of that is going to be looked at to see if they really want to stick to that program or change things entirely. We're going to wait and see.
Thank you. And I believe we have some questions from Edwin, our panelist.
Hi, Tariq. Thank you so much for the wonderful presentation and the overview of all the various rocket programs. I have a couple of questions. The first one is, are you familiar with this aerospace company, Relativity Space?
Yes,
They're based
yes.
in Long Beach. And I believe in 2023, they successfully launched the world's first 3D metal printed rocket.
That's right.
So are they still in the game?
Well, last I heard they are, but they're developing like their own like larger like fully reusable rockets themselves. So you know I had heard that they're having some funding challenges right now. And so we are waiting to see how that shakes out to see if they're able to get all the way through for their next mission. But they do have a lot of contracts in place that could secure their position going forward. They want to build a medium lift rocket and then scale up to a fully reusable big rocket, kind of like a Falcon Heavy.
Okay. Quick follow up. What about this company that launches rockets using a centrifuge?
The spin launch, I think, is what they're called. I think that's really interesting. I've seen how they do it, and it looks really wild. But it wouldn't be really great for crewed vehicles because they really got to whip it really fast to slingshot it up into space. It is a novel launch attempt too, and in fact, there's also some other. There's another company called Starfighter, and they're using like F-16 jets to launch satellites into space. Now they're not where they need to get to yet, but they've got these two different ways to try to limit the amount of rocket engines they have to put into it.
Okay, maybe good for small satellites.
Yeah. Exactly.
My other question is, before I turn it over to Imelda, everybody has seen the mid-air capture of the Starship booster by the chopsticks, which is really amazing. However, my question is, wouldn't it be simpler from an engineering standpoint to just land the booster on the ground, on the launch pad, rather than catching it in midair? Would it be simpler, easier, and safer?
It would be simpler for sure. Now, the reason that SpaceX is doing this is because they really want to cut down the amount of time it will eventually take to turn the rocket around and launch it back into space again. So by returning it right back to the launch pad, it's back there now. They can clean it up, inspect it, and then refuel it all in the same place and get ready to launch it again. You know, if you recall, they have to launch something like 15 to 24 of these missions just to refuel one Starship to get it to the moon. And so they really need to scale down the amount of time for turnaround. So this will allows them to remove a lot of crane pickup, driving over another crane to get it back on the pad by just having it land on the pad in the first place. But you are right, Edwin. It adds a lot of complexity.
Yeah, because it's the booster is suspended in midair, several stories high, and they would still have to lower it to the ground in order to work on.
Yeah, well, they lower it onto a test stand. Yeah, so eventually they want to never have it leave the pad. So they catch it, they lower it on the pad, they launch it, it comes back to the pad, they fill it up, they launch it, it comes back to the pad. They want to just keep it there all the time.
And Imelda has a quick question.
Just me, quick one. With all this launch, I was born when, later on we had launches, but not this much with multiple countries launching, multiple companies launching. What is the environmental impact, particularly not just on, the chemicals that gets deposited on the ground, the contamination, but also onto wildlife?
It is a really good question, Imelda. In fact, that was part of the discussion at AAS is about the reentry and then the launch exhaust contamination that is coming up from this massive uptick in spaceflight and these rockets themselves. And so it is something that's being studied right now because it is significant, this additional launch rate. SpaceX in particular is having a lot of back and forth with regulatory and environmental agencies in the Boca Chica region because it is a wetlands and a wildlife refuge where they built that. And as you'll recall, Merritt Island, where the Kennedy Space Center is also a wildlife refuge. And so they are in the midst of an environmental review there as well for the launching Starships there too. There is an impact that they're trying to offset with either securing other land to have that preserved and whatnot. But it's being looked at very closely right now because we are still very early in these rocket processes right now.
I'm glad to hear that, Tariq, because, I don't mind, killing all the mosquitoes near the launch pad, because as you remember back then, when you saw us back at the press office, we had so much mosquito bites.
Yeah.
Thank you.
Thank you.
There's a comment here from Mr. Junlao, one of our panelists. SpaceX tried to land the boosters before on ships. The boosters tended to tip over and falling, while simpler, it failed more often than not. Yeah.
Yeah, that's true. That's actually why SpaceX has special weather criteria now for offshore landings, because they want to make sure it's very stable. They also have a little robot that goes underneath the rocket now and clamps on the feet to keep it from sliding around.
Okay. So maybe we can have time for one more question from our panelist. Alan, do you have a question?
Yes, I do have a question. Lately, on this from this decade, last decade, we've seen China, India leading the space race. My question is, how did China get so fast to land spacecraft on Moon and Mars? Were they able to copy anything from NASA, or NASA was for all these years have been sharing some technology information with them? That's why they managed to accomplish so much in such a short time.
I'm sure, Alan, that there was a lot of study on what worked from NASA technology as well as technology around the world. NASA's studies are usually a public domain, which means that you can look at what they built and the structures and everything over time. However, China did two things. Number one is they licensed a lot of technology from Russia when it comes to human spaceflight. So there's a reason why their Shenzhou spacecraft, their space stations look very similar to Russia's Soyuz, but they actually added a lot of new technology into that to be able to make them more robust. So their Shenzhou spacecraft can stay in orbit much longer than the Shenzhou the Soyuz vehicles because they're a little bit more enhanced. They're a little bit more roomy. They have different types of technology built into them. But what China did for the moon was very interesting. They built what they thought was a very dedicated and dependable platform for their Chang'e series, and when it worked, they basically enhanced it and made new additions. They didn't try anything that was too beyond the pale, right? So it was very similar to what was working before with a few extra things to make it better. And they did that type of iteration time and time again, and they were able to get the technology to a point where it was very dependable, like a bus to land the regular types of missions on the moon. So using that baseline, they were able to then build tailored landers over time, so they know what works, and each time it's more and more successful. They added a rover. That rover worked, so when they launched the next one, they added the same type of rover, but with a different type of set of instruments. That's the kind of changes, and by doing that slowly and doing it steadily, they were able to succeed and make sure that they weren't launching anything that wasn't 100% ready to succeed. It's been very interesting to watch over time because those missions have about 100% like success rate. Now they've landed on the far side of the moon. They've returned samples to the Earth. They're going to try to land at the south pole of the moon and return samples from the far side in the future. So,
Thank you, Tariq. Thank you so much for your patience in answering the questions. And we have to move on because Mr. Alan Hale has to give his talk as well. But before that, we would like to present you with our ALP Certificate of Appreciation for your talk. And let me read it. This certificate is presented to Tariq Malik for the webinar entitled "The Importance of Preserving Astronomic." For the webinar entitled "The Rise of the Giant Rockets, Starship, New Glenn, Vulcan, and SLS." Given this 19th day of January 2025, signed by yours truly, Dr. Jose Francisco Aguilar, President, and Andrew Ian Chan, Vice President. Thank you again so much for your wonderful talk, Alan. Thank you, Atari. And let's wait for Alan to give his talk. If we would like to ask you to stay as well.
yes, of course.
Okay.
Thank you, Jed. Thank you, everybody. I really appreciate that.